Okay, in this example, we're going to discuss about probability plus with permutation. Okay, let's try to read this question first. 3 red marbles, 4 yellow marbles, and 2 green marbles are arranged in one row on a table. Find the probability. A. All the 4 yellow marbles must be next to each other. B. All the 4 yellow marbles must not be arranged next to each other. And lastly, C. The green marbles must be in the first and the last positions of the row. Okay, first, how we can identify this example is using permutations. Of course, it's coming from the keywords of arranged. Okay, this question is clearly mentions about the arrangements of the marbles on a row, on one row. Then we can say that this example we have to use permutations in order to find the probability of these problems. First, what we're going to do is, of course, the first thing I'm going to list down again all these informations where we have three red marbles. Okay, 3 red marbles, and we have 4 yellow marbles, and lastly we have 2 green marbles. Okay, which is total overall we have 9 marbles total overall. Okay, and first, okay, the first thing I'm going to do is, okay, I'm going to find the total sample space. Okay, as we may concern that these marbles we need to arrange on a table, okay, in a one row. So the first thing I'm going to do is, since this is actually the permutations with identical object, if you still remember, we have to use factorial in order to find the arrangement. So first, for the total sample space, which is denoted by an S, this will be equivalent to 9 factorial. Okay, since we have 9 marbles, divided with identical object, which is we have 3 red marbles, 3 factorial, times with 4 factorials, 4 yellow marbles, times with 2 factorials for the green marbles, whereby this will be equivalent to 1260. Okay, then in order to answer for the A, so A, we are going to find the probability of all the 4 yellow marbles must be next to each other. So in order to illustrate this problem, okay, so let me draw these places first. Okay, so we have 9 need to be arranged of the marbles, 1 2 3 4 5 6 7 8. Okay, so these 4 places, okay, will be placed for the yellow marble. Okay, so since we are going to place these 4 places for the yellow marbles and it must be seated next to each other, then we have to consider this as a one place. Okay, so by total up of these places, including of these 1 places, therefore we still have 6 remaining places in order to arrange them. Okay, so therefore, in order to find this probability of these cases, first of all, I'm going to let event A. Okay, so I'm going to let A be an event that 4 yellow marbles are arranged next to each other. Okay, so now we're going to find the total of event A, which is equivalent to, since we have a 6th place, okay, including this place, so we're going to do the 6 factorial divided by we have 2 remaining identical object, which is red marbles and also green marbles. So we have to divide by 3 factorial times with 2 factorials. Okay, therefore this will be equivalent to 60. Okay, so now in order to find the probability of A, Okay, so this we have to use the definitions of the probability, whereby we have an A divided by an S. This will be covalence to 60 divided by 1260, okay, which is equals to, after simplify, we have 1 over 21. Okay, then we move to the next example, which is B. So now we would like to find the probability of all the 4 yellow marbles must not be arranged next to each other. So if you can see these words, okay, the 4 yellow marbles must not be arranged next to each other. So this is actually the words of complement of the event A that we just declared just now. So in order to solve for B, what I'm going to do is, okay, so we know that since B, the cases of B is actually the A complement, so I'm going to declare as the A complement here, which is A prime, which is denoted for A complement, which an event for 4 yellow marbles are not arranged next to each other. Okay, so by using the formula of complements, if you still remember, the probability of A complement will be equals to 1 minus probability of A. So since we already have the value of PA is 1 over 21, then we just calculate 1 minus 1 over 21, okay, which means we are going to have 20 over 21. Okay, and then we look at C. Okay, C, we have to find the probability. The green marbles must be in the first and the last positions of the row. So let me just illustrate the same thing here, which is C. Let's say that we have 9 places need to be arranged of the marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this first and last positions, we have to put the green marbles. So we just have 2 green marbles, and then we have put first and the last position and the last place, and then we still have a 7 remaining. We still have a 7 remaining places need to be arranged. Okay, so these 2 placed first and last is already been arranged for the green marbles. Then what we do is we're going to declare as event B for the event for the green marbles to be in the first and last position. Of the row. Okay, so now we're looking for NB, total of event B, which is equivalence to, since we have 7 remaining places that need to be arranged, then will be equals to 7 factorial divided by, so green had been selected, therefore we still have 2 identical objects left, which is yellow and red. So 3 red and 4 yellow, so therefore we have to divide by 3 factorial times with 4 factorial. Okay, so this will be equivalence to 35. Okay, the probability of B will be equivalence to NB divided by NS, which is equals to 35 divided by 1260. After simplify, we're supposed to have 1 over 36.